Hello everyone. Let's take a look at this question. Show that in Fanno line process, specific entropy X depends on the specific entropy using the equation. Then 2. Sketch the HS diagram for the Fanno line. Now, don't let us forget that Fanno line is a constant dot process. With a friction with no in transfer. So it's an adiabatic process that entails the flow of fluids with a friction but with no in transfer. Now, how do we deduce the formula? Don't let us forget that we were given to show that the S equals CV natural logarithm HO minus H raised to power gamma 1 over 2 plus constant. In which we know that rho V equals constant and H equals, that is the entropy, equals CP T. Now, by substituting all this into equation for the entropy of the gas, we can deduce that the S equals CV dt T minus RG dP rho, which equals CV dHH plus RG dVV. Don't let us forget that this is for the perfect gas. And if that should be the case, by integrating all this, that is, by integrating them on a long term, integrating and substituting Rg equals gamma 1 CV. By integrating and substituting Rg, that is gas constant R, then we can deduce that the S, that is the entropy, equals CV square bracket natural logarithm of entropy plus gamma minus 1 natural logarithm C plus C. And if that should be the case, where C, that is the constant of integration, C is a constant of integration. From there we can deduce that Cs, that is the entropy, equals Cv, natural logarithm, h v gamma minus 1 plus c. And don't let us forget that HO equals h plus v squared over 2. Now from here, you can deduce that V equals 2 HO minus H square, which becomes root 2 HO minus H to the square root. Then our SH becomes CV ln H HO to H gamma minus 1 over 2 to the square root of 2 plus C. And this can be rewritten. We adjust by saying SH equal CV natural logarithm of HO minus H over 2 plus C1. And don't let us forget that C1 equals C plus CV ln root 2. QED. That is solved. Now don't let us forget from the equation where it has to sketch the HS diagram for the Fanno line. That is the entropy diagram. Now, the HS diagram. Plot for an average Fanno line. It's going to go with the trend. Of such, whereby this is the HO, that is a stagnant entropy, and this is the entropy, and this will become the X mass, that is the maximum entropy, X mass. Why this part becomes the critical entropy. And this is H1, S1, and the Mach number will increase from this subsonic to hypersonic from here, that is m greater than 1 here, and it's going to decrease here, that is the Mach number less than 1, and this part is going to be sonic, m equals 1, sonic, subsonic, supersonic. And this schematic is what we call the HS plot for the Fanno line. Thank you very much.